Good morning, students. This is Dr. Eustace Russell working as Assistant Professor, the Department of Mechatronics Engineering at Sri Muthukumaran Institute of Technology. So far, we are discussing the subject called Robot Dynamics and Control, subject code RA3601 under the regulation of 2021 for the sixth semester for the third year students. Last class, we have completed Unit 4. 3 lecture videos we have completed, various control manipulators, MIMO stability analysis also we have discussed, with some real-time applications also we have discussed in the previous videos. Now we will see the last few topics from this same unit. This is the syllabus for your reference, students. Today we are going to see some important topic, that is advanced manipulator control techniques. So in previous videos we have seen normal control techniques we have discussed, how it will be controlled by using sensors, non-linear, linear. Here various techniques, how it will be attained to manipulate the control. That is Lyapunov stability analysis, Cartesian based control systems, adaptive control, limit cycle, describing function method. Concept of stability, that is Lyapunov stability analysis. In this, a system is stable if small disturbances do not cause large deviation from the equilibrium state. So even though small disturbances, it should not cause a large deviation. That is, this stability analysis is implemented. Equilibrium point, that is important. That is, types of stability is nothing but stable, that is semastically stable, unstable. Why this stability? That is Lyapunov stability, why it is needed. Traditional methods require solving differential equations. Lyapunov method determines stability without explicitly solving the system. That is, that we can see that is neutral equilibrium. We can see that neutral equilibrium, stable equilibrium, unstable equilibrium. So various techniques we have seen in the diagram. Importance in robotics is nothing but robot trajectory tracking, joint stability, manipulator control. Lyapunov function concept. This function is analogous to the energy stored in a system. The condition, various conditions you have seen in the previous videos also, some condition we have implemented. Here also the same thing we are using, positive definite. That is, V of x is greater than 0. At equilibrium, V of 0 equal to 0. Negative definite, that is V dot x less than 0. Interpretation, if system energy continuously decreases, the system eventually settles at equilibrium state. So for example, V of x is equal to x square. We are going to differentiate that. That is, everybody know that the differentiation of x square is nothing but 2x. Again, the differentiation of x is defined as x dot. Application used to prove the stability of robotic manipulators. Here, for your understanding purpose, I have mentioned the theorem, the direct method for the local stability, which I have highlighted here. So for a given system, x dot in mathematical, everywhere we will declare with one variable. Here we are going to declare with x dot equal to f of x, with f continuous, and for some region around the origin, if can produce a scalar continuously differentiable function v of x such that some mathematical condition is mentioned over here. V of x is greater than 0. V dot, that is differential of that v is equal to dou v by dou x, f of x less than or equal to 0. Then the origin s is equal to 0 is stable in the sense of Lyapunov. If additionally we have v dot x is equal to dou v by dou x, f of x less than 0. Again, the origin is locally stable. Then we have v dot x is equal to dou v by dou x. is equal to dou v by dou x, f of x less than or equal to minus alpha v of x, then alpha greater than 0, then the origin is locally exponentially stable. Cartesian control. This is another one control technique we are using. There is position error. E is defined by xd minus x. S is the desired position, x is the actual position, which I already seen in the previous videos. One state to another state, initial state to the attained state, that is a desired position, how much it has to move from one point to another point. Cartesian controller is defined by f is equal to kp xd minus x plus kd x dot x minus x dot. Components. Proportional, that is various proportional term reduces position error. Derivative term reduces oscillations. Various benefits highlighted here: smooth motion, accurate tracking, better workspace control, various application of welding robots, surgical robots, pick and place robots. Pick and place robots, this control Cartesian will be used very useful in that. The first unit we have seen that various Cartesian state system. In that also pick and place robot also will be highlighted. Adaptive control. Need for adaptive control is robot parameters may change during operation due to payload variation. Payload variation also we have seen in the previous videos. The load may get changed. That is not be constant. Sometimes the robot will have to lift the increasing in load. So friction changes. Always the friction will not be same. Maybe it may change. Wear and tear. If friction changes, automatically wear and tear will be there. Environmental disturbances. Then traditional controllers may not perform well under such conditions. Then adaptive control. Automatically adjust controller parameters based on system behavior. Features. Self-tuning, robust, handles uncertainties, application industrial manipulators, space robots, autonomous robot. Now we can see adaptive control system architecture. Here we can see desired performance, comparison decision, adaptation mechanism, performance, measurement. Then system or planned, adjustable control. The various the loop system will be followed like this. The desired performance, then from the adaptation mechanism, again it is going to the adjustable controller, then control input, system or planned, then finally to the output. Adaptive control automatically adjusts controller parameters to maintain desired performance when system dynamics change due to disturbances, uncertainties, or varying operating conditions. Working principle is nothing but we are having the reference signal that is specify the desired output. That is what output you have to attain. That is, it specify that one. Adjustable control generates the control input. System planned produces the actual output. Performance measurement monitors system behavior. Comparison decision evaluates the error between desired and actual performance. Adaptation mechanism updates controller parameters to reduce error and improve performance. Then we have the limit cycle. Limit cycle is nothing but limit cycle is a self-sustained periodical oscillation that persists even without external excitation. Characteristics: repeating oscillation, fixed amplitude, closed stability in space plane, causes in robotics, friction, non-linearities, actuator saturation, relay control, dead sword effect, consequences, reduced precision, increased wear energy. These are the disadvantages we can see. Describing function method, the various purpose. The describing function method is an approximate technique used to analyze non-linear system. Replace a non-linear element with an equivalent gain and space shift. Predicting limit cycles, stability analysis. These are the applications. Servo system design. Various advantages, symbol analysis useful for weak non-linearities. Limitation approximate method only. Only for approximation only we can go for this function method. So we have a glimpse of the summary and industrial relevance, that is Lyell stability. It determines stability without solving differential equations. Cartesian control, control robot motion directly in workspace coordinates. Adaptive control, automatically adjust parameters. This is the adaptive one. Limit cycle represents sustained oscillation in nonlinear system. Describing function analysis nonlinear behavior using equivalent linear model. Industrial main application is industrial welding robot, surgical robot, space manipulators, autonomous vehicle and precision assembly systems. These are the various references which I used for preparing these various contents. Kindly go through the reference, students. Thank you all for your kind attention. We successfully completed unit 4, that is control manipulators. So in upcoming video we will start with 5th unit. Kindly subscribe this video, share this video to your friends. So we will meet in the upcoming lecture videos. Thank you, students.